And now let's go over a lunar eclipses overview, just a mainstream overview of it, just to catch up on some planetary science. All right, so a lunar eclipse occurs when the moon moves behind the Earth's shadow. And a solar eclipse is when the moon moves directly between the Earth and the sun, thus obscuring the sun from a particular spot on the Earth. And here's an image right here. So these are nodes. I'll explain that. So the lunar nodes are 2 points where the moon's orbit around the Earth, so there's the orbit, goes like that, around it, meets Earth's orbit around the sun. So this is Earth's orbit, and there is the moon's orbit, and this Earth's orbit around the sun is called the ecliptic, and the moon's orbit is inclined at about 5% relative to the ecliptic. So this is, if this is around there, so it's inclined that this is 5% right there. The 5% inclined. And again, the nodes are when they intersect. So when they intersect the ecliptic or the moon's orbit, so here in this case, the nodes would be lining up in front of the sun. But in this case here, they would intersect around here and here. So then there is no solar eclipse or lunar eclipse. And this one would be connecting here and here. So those are the nodes. But then in these scenarios, when it lines up right in front between the sun. So this is solar eclipse is when the moon is between the sun and the Earth, and there's the lunar eclipse when it's in the shadow there. Notice the two shadows here. You'll have the darker one coming in like this, then you'll have the lighter one going. Yeah, I mean the darker one goes like this, and then the lighter one goes from the inside out, and so on. So you have those two shadows, and there's the other side, solar eclipse, lunar eclipse over there. Very, very interesting. Let's continue further. Let's look at a better image, or just a different image. So you have a solar eclipse right here is when this is in front. There's a shadow, the dark side, and then there's the penumbra is the lighter shadow coming from the inside out. So it goes from here, and then versus the other one goes straight across like that. So there's the solar eclipse, and so inside here will be dark, and you see the solar eclipse, and on the outside you have the moon on the back side. And there is the shadow there. The penumbra is the lighter shadow. So yes, source, solar and lunar eclipses. This image is just the image itself. This one is typically Wikipedia or a website that gives information on it. Anyways, and here's another image showing the different types of shadows here. So here's a shadow classifications, Umbra and Penumbra. This is for a typical scenario for lunar eclipses. So you have the moon going across here, and then the penumbra is the lighter shadow, and there is the darker one in the umbra in this central region there. So, and lunar eclipses can be classified as penumbral lunar eclipses. Moon passes through Earth's penumbra. That's this right here. So these are penumbra lunar eclipse. Then you also have partial lunar eclipse. Only a portion of the moon passes through the Earth's umbra. So only if you have, let's say, in between here, like where my mouse is right there. And you can have a total lunar eclipse. The entire moon passes through the Earth's umbra, goes all the way across it there. And central lunar eclipse, total lunar eclipse in which the moon passes through the center of the Earth's shadow, as Trump's one just touched the center there. And these ones appear darker than other lunar eclipses and is relatively rare. And going further, so during total lunar eclipses, the full moon tends to look reddish, hence called blood moon, because the Earth's atmosphere scatters blue light more than it does red light. So you'll have the sun here, the sun rays, and then the blue light's higher frequency and shorter wavelength, so it typically gets scattered in the atmosphere, so it scatters more out, while as the red wavelengths, which are longer and shorter frequency, they can go through, so they'll go like this. They'll typically go through, whereas the blue one goes like this and probably hits a lot of the atoms and flies around and so on. Again, this is mainstream overview of it. And then so what you're left with is these reddish rays there. And then you'll have this red-looking moon there in the shadow. So Earth's atmosphere scatters blue light, red light passes through and falls onto the moon, so that picks up. So yeah, source here, so blue light scatters more than red light, causing a reddish moon appearance, hence blood moon. And here is a comparison of solar eclipse versus a lunar eclipse. This one here is blocking out the sun, but notice the sun's corona around it. Very interesting. And there is the reddish moon right there, so the blood moon.